Welcome to the Federal Aviation Administration's Avoiding Airplane Upsets video. This video is a product of the FAA's Safer Skies Agenda, a renewed commitment between FAA and industry to develop educational programs designed to reduce the number of aviation accidents.
Hi, I'm Sean Elliott, the President of the National Association of Flight Instructors. One of the most important missions of our organization is safety. Most flight instructors define safety as minimizing risk through quality training and education. The members of the IAC, or International Aerobatics Club, share this definition. The IAC is a competitive aerobatics organization, but more importantly, its focus on safety affects all types of pilots flying all types of aircraft. The IAC has enjoyed an outstanding safety record over its 30-plus years of aerobatic competition. It's because of this expertise, along with the educational focus of NAFI, that the FAA has commissioned the IAC to develop the program you're about to see. I'm certain you'll find the program both informational and educational, but most importantly, I'm certain you'll find it of value in making you a safer pilot.
Mike Goulian can boast such accomplishments as being named U.S. Unlimited National Champion, being a three-time member of the U.S. National Aerobatic Team, and securing multiple medals at the World Aerobatic Championships. Goulian is also a certified flight instructor, specializing in aerobatic instruction. In his spare time, he amazes crowds with spectacular airshow performances. Julie Savage earned her certified flight instructor's rating while completing her bachelor's degree at Southern Illinois University. Julie has competed successfully on the precision flight team at SIU, and in 1999 won top female pilot in the nation at the National Intercollegiate Flying Association Safety and Evaluation Conference. Julie currently flies for American Eagle Airlines based out of Chicago O'Hare Airport. In her spare time, she serves on the foundation board of the Experimental Aircraft Association.
The FAA has identified 6 categories into which a large majority of general aviation accidents can occur. Number 2 on that list is loss of control. The loss of control associated with an unintentional airplane upset has become a popular topic in recent years.
It certainly has. So much so that several airlines and corporate flight departments have added upset recovery training to their recurrent training programs, and even NASA funded a study to determine the potential benefits of hands-on upset recovery training.
In this program, we'll take a closer look at 3 classic airplane upset scenarios. Each is associated with rolling, possibly to high angles of bank. All are accident scenarios that continue to get pilots into trouble. We'll also discuss strategies to help you recognize and avoid situations that can lead to these or similar roll upsets.
But first, let's define what we mean by a roll upset. For our purposes, a roll upset involves any uncontrolled or uncommanded change in your airplane's bank angle. As the bank continues to increase, it usually becomes more and more difficult to maintain the desired heading, altitude profile, airspeed, or attitude.
For example, if you are intending to cruise along in wings level flight at a constant altitude, but the airplane suddenly rolls over to 90 degrees of bank, you are experiencing a roll upset. With this in mind, let's look at our 3 scenarios. Roll upsets have been with us since the beginnings of power flight. These potentially disastrous scenarios have been, and continue to be, concerns that we, as responsible pilots, must deal with.
The first roll upset scenario develops from a botched turn and results in an uncontrolled descending spiral. Although the process leading to this upset can start from any bank angle, it's usually associated with steeper bank turns. While attempting to turn, the pilot unintentionally allows the bank angle to increase without simultaneously increasing back elevator pressure. The pilot is slow to react as the nose of the airplane drops below the horizon.
Airspeed increases noticeably as the altimeter and vertical speed indicator show a rapid loss of altitude. Meanwhile, bank angle remains high due to the natural overbanking tendency of the spiraling airplane. Reacting now to the accelerating nose-low attitude, the pilot instinctively pulls back on the elevator control trying to get the nose up. Unfortunately, this action only tightens the descending spiral.
Frozen on the controls, holding aft elevator, the pilot is unable to recover from the spiral. Prior to ground impact, the airplane may suffer structural failure as airspeed and G-load design limits are exceeded.
The next scenario involves a weather-induced upset, perhaps as a result of turbulence in the atmosphere, mountain waves, or thunderstorm activity. Flight into icing conditions poses multiple hazards to the pilot as well, including the potential for a roll upset, even if the airplane is equipped with an anti-ice system.
The pilot is flying in instrument conditions on the autopilot. The weather is conducive to icing, with visible rain and freezing conditions. Large droplets splatter on impact with the windshield. Small streams of water streak across the side windows. Ridges of ice begin to form on the wings ahead of the ailerons. Masked by the autopilot, the pilot is unable to sense an unusual vibration in the control wheel. The autopilot disengages as the ailerons deflect suddenly to the control stop. Caught off guard, the uncommanded roll causes the pilot to pull back on the elevator control as the airplane rolls inverted. In the third upset scenario, air traffic control sequences a small airplane behind a larger, heavier aircraft miles ahead. The pilot is cleared for the visual approach straight in and is cautioned about the possibility of wake turbulence.
Ambient lighting conditions, however, are such that the pilot of the small airplane is not yet able to see the traffic ahead or its flight path. The winds are light with barely a hint of a quartering tailwind. The air is smooth. Assuming the heavy traffic is flying precisely along the 3-degree VASI glide slope, the pilot of the small airplane sets up to do the same. The pilot begins to fixate on the approach.
As the approach continues, the pilot encounters a bump in the air, followed quickly by another. Then the airplane rolls sharply beyond 90 degrees of bank. The pilot's delayed reaction is a timid attempt to apply opposite aileron as the airplane rolls inverted. The unusual attitude, sudden loss of altitude, and loosely secured seatbelt cause the pilot to pull back on the elevator control.
These accident scenarios actually share a number of common traits. In each case, the pilot did not recognize warning signs until the scenario turned into a full-blown unusual attitude.
The pilot's situational awareness was compromised prior to each roll upset as well.
Corrective actions either were initiated too late or were not applied fully to counteract the increasing angle of bank.
And in each case, the pilot's natural instinct to pull on the elevator control aggravated the situation and detracted from the pilot's ability to apply corrective aileron.
Pilots use the terms roll and bank interchangeably to describe how the aircraft moves about its longitudinal axis. The longitudinal axis is an imaginary line drawn from the nose of the aircraft through the tail.
And we roll about the longitudinal axis usually using the ailerons. And when we use the ailerons to roll, we actually are changing the shape of the wing.
By deflecting the ailerons, we are changing the chord line. The chord line is also an imaginary line that runs from the leading edge of the wing through the trailing edge. When we change the chord line in relation to the relative wind, we are creating an angle of attack.
When banking in normal, unstalled flight, the upward deflected aileron, the aileron on the same side as your roll input, tilts the local chord line forward, instantly decreasing the local angle of attack. This results in a decrease in the net lift on the up aileron side of the airplane.
On the